Hey, and welcome. In this tutorial, we'll walk through running a synthetic workload on a Postgres database and optimize its performance using DBtune. Here's what we will cover: setting up a virtual machine to run a Postgres server, loading demo data into the database, running a synthetic workload, optimizing database performance with DBtune. Let's start by heading over to our demo repository on GitHub. It's called synthetic_workload, and you can find the link in the video description. We will be using a virtual machine created on Azure, but the guide also works with AWS. With a few tweaks, you could use it on any cloud provider. For this tutorial, we'll be using an Azure VM with 8 vCPUs and 32 gigabytes RAM, which provides sufficient resources for our benchmark. Now let's open the terminal where we've established an SSH connection to our already created VM and clone the synthetic workload repository. Before we run this setup script, we need to identify which disk to mount for our data. Since we'll be loading potentially hundreds of gigabytes of data and Azure VMs come with limited OS disk space, we'll use the ephemeral disk. Let's run the list block devices command to see available disks. As you can see, our ephemeral disk is in VME1N1. We'll need to export this as a variable. Now we can navigate to the repository folder and run the setup script. Currently, we support Ubuntu automation scripts, though modifying them for other Linux distributions would be straightforward. Let's run the script. The script accomplishes several key tasks: set up the environment, as of setting the Postgres environment variable to the appropriate version, and the name of the mounted disk, updates Ubuntu and install required dependencies like Python and the Java runtime and packages, adds the Postgres repository and installs the Postgres server and client tools, install Benchbase, an open source benchmarking framework. This step creates a Benchbase Postgres folder alongside the synthetic workload folder, prepares the database with appropriate user creation, and adds the pgstat statement extension which DBtune uses to fetch the database performance, mounts the data directory, and configures the Postgres SQL settings appropriately. As the installation script runs, let's discuss what Benchbase is. Benchbase is an open source benchmarking framework written in Java that provides out of the box many evaluation workloads to test on your database management system. We prefer using this framework from others like pgbench, as it offers workloads that are more representative of realistic conditions. Now that we know what Benchbase is and our installation script is finished, let's go to the next step. For this tutorial, we'll use the opinions benchmark. It simulates a RAID-heavy workload inspired by a product review site where users browse, rate, and interact with content. This makes it a great fit for showcasing how DBtune enhances query performance in analytical and content-driven applications. Since we'll be running processes for an extended period, we can use a terminal multiplexer like Screen or tmux to prevent process interruption if the SSH session disconnects. Let's use Screen and start loading data. To load the data, we will be running the Benchbase load command, which will create the data from scratch. This process is quite time intensive. For the opinions benchmark on our Azure VM, it takes approximately 9 to 10 hours. Loading times can vary based on your VM size and disk performance, so plan accordingly. Let's start this process and get back after it completes. Now that the data is loaded, let's quickly validate that everything is in place by connecting to the database using the PSQL CLI tool. We'll run a query to check the size of the Benchbase database using the credentials created earlier by our setup script. As expected, the data has been imported successfully with approximately 88 gigabytes of data now in the database. With data in place, we're ready to execute our workload using Benchbase. Let's run the Benchbase command. It appears to be working correctly. We'll now let the workload run for about 2 hours. This warm-up period is important to allow the database cache to fill and for the workload to reach a steady state, which ensures more accurate performance measurements. Let's go ahead and detach this screen session so it continues running in the background. Next, we'll connect DBtune to the database. To get started, head over to the DBtune platform. If you don't have an account yet, go ahead and create one. Since I already have an account, I'll log in using the Login with Google option. Next, we'll create a new database instance. I'll name this one Synthetic Workload Tutorial and click Create Database using the default options. Once the database is created, you'll be redirected to the DBtune agent setup page. Let's follow the instructions to connect the agent to our database. Some steps, like creating a new database user, can be skipped since our synthetic workload script already created a user named admin with the password. However, we still need to install the pgstat statements extension, which DBtune relies on to collect the query performance metrics. So let's go ahead and create it. Connect using PSQL and enter password when prompted. The DBtune agent is available either as a precompiled binary or as a Docker image. For this tutorial, we'll be using the binary version. Now let's download the agent binary. Once it's downloaded, we'll create a dbtune.yaml configuration file and paste in the content provided by the platform. You can use any text editor to do this. In our case, we'll use Vim. Next, replace the connection URL in the config file with the one from the guide using the database that we loaded our data into and which was created by our setup script. Note that data won't appear instantly in the DBtune dashboard. It may take a few minutes for the agent to start collecting and reporting metrics. So just give it a bit of time and you should start seeing data flow in shortly. Let's start the agent and switch back to the DBtune platform. After a short wait, key metrics should appear on the dashboard, and here they are. Looking at these charts, we can see that our average query runtime is currently around 3 to 3.5 milliseconds, which will be our primary optimization target. The transactions per second chart shows we're handling about 4,000 to 5,000 transactions per second with the opinions workload. At this point, our 2-hour warm-up period has completed and the system has reached a steady state. Now that we've confirmed the workload is running properly, we can head to the tuning tab and start a tuning session. We'll perform a reload-only session using the default settings. In this case, we're optimizing for average query runtime. In simple terms, we want to improve how quickly PostgreSQL executes incoming queries. So with that in mind, let's click Start Tuning. The first 5 minutes will be spent measuring the baseline performance of the system. That is, how the current PostgreSQL configuration performs in terms of query latency, our tuning objective. After that, DBtune will recommend a new configuration every 5 minutes. We'll fast forward now and come back shortly. All right, we're back, and the tuning session has completed. Let's take a look at what DBtune managed to achieve. We were running with a 5-minute iteration window, and in just under 3 hours, the tuning process completed. And the outcome? The results speak for themselves. Average query runtime dropped from around 3 milliseconds to just 0.7. That's over 4 times faster. TPS also went up by about 4 times, hitting more than 18,000 transactions per second. Let's just take a second to let that sink in. A 4x performance boost with 0 manual tuning all in a few hours. Now let's dive into what changed under the hood. First, here's the base config. These were the default settings we started with. And now here's the best configuration DBtune discovered after multiple rounds of tuning. A few standout changes: random page costs dropped from 4 to 1.5, which makes the planner prefer index scans, really helpful for workloads like opinions. Parallelism was disabled with max parallel workers per gather set to 0. This prevents the planner from choosing parallel execution paths, which can be beneficial for workloads with high contention or short query runtimes like opinions. If we scroll down, we can see how performance improved across each iteration, and we can click into each bar to explore the exact parameters that were used. It was that easy to evaluate DBtune on a workload designed to simulate real-world database traffic. With just a few steps and no manual tuning, we were able to significantly improve performance, both in terms of query latency and throughput. And the best part, when the tuning session ends, DBtune automatically applies the best configuration to your database. So you continue to run with optimal performance going forward. That wraps up our tutorial on running a synthetic workload and optimizing Postgres with DBtune. To learn more, visit www.dbtune.com, sign up, and start optimizing your Postgres databases today.